In this video, I'll walk through how to program a different 5-axis part through the 3D-5X module. So we'll just click on it here. And for this one, we're going to assume that this is a water-only 5-axis. And I'll just choose foam. Okay, so we'll go and grab sample here. So I find this model particularly fun to work with. A lot of interesting things that you can do in this one. So we've got a few different cuts that we can do here. We've got a vertical hole. We've got this hole that's at an angle. We'll have a bevel cut along the edge here. We've also got a bevel cut along the edge here, which intersects with that bevel cut. And then we've got vertical cut along here, and those sides there. So there's a lot of neat things that you can do with this one to make it come out in an acceptable fashion. So first of all, what we'll do is we'll see how this is oriented on our table. So if we wanted to cut this left to right on the table and we're just cutting a single part, we're not going to be nesting it, we can rotate the part. So if we go into our Cam tab, under the Align submenu, there's this option here to rotate, and this will rotate the model around whichever axis. So if we want to rotate this 90 degrees around the z-axis, click that. If that looks good, I can close it. The model is sitting on top of the table, so we don't have to use the ground or align button there. And then I would normally set my 0 point at this point. Right now the 0 point's there off in space at the top of the table. We'll set our 0 point at the top left-hand corner of the part. That's where we'll start our cutting head. So we got the 0 point command here, and then since my snaps are turned on, which are down here, we've got our snapping options, and if you want to change those, you can click on that and choose your different snap points. Then we can just click and move our 0 point to the corner there. So now we can go through and start picking edges to work off of. I'm going to basically work with one cut at a time, so we'll go back and forth between the curves and the tool path. So first we'll start with easy one here, this hole here. So we'll go to our curves command, and we'll go ahead and pick surfaces. So a lot of times you'll find that it's actually easier to work off of a bottom surface than trying to work off the top surface. So for this here, the hole, if we look at the top surface, there's not a very clean curve that would give us that hole. We could do some CAD editing and draw in an arc here, or we could project this up to a surface. But the easiest thing would actually be just to pick this bottom surface here, and it gets that circle, which we'll then be able to add our toolpath to. So that's all I'm going to do for right now. And let's spin this around here again. So we've got that there. So up here it has found that curve, and this curve actually isn't going to end up being very useful to me, because for the outside cut we're not going to want to cut in there. So I'm just going to go ahead and delete that one for now so I don't pick it by mistake. So now we'll go to toolpath, and we'll go ahead and click on plus, and upper curve, I'm actually going to pick this curve at the bottom because right now that's the only curve I do have, and then click where I want to do my pierce and hit enter to go all the way around, and then which direction I want to go around the cut. And now it's looking for information about the lead in and lead out. So I'll go ahead and give myself a bit of a lead in, so my cursor snaps in, that line snaps in at that point there. I hit enter, and then if I want to give myself a little bit of lead out, can hit enter there. And then if this is water only, probably don't really need any lead out, and we'll just do a shorter lead in there. And then for water only cutting, you can set this lead to either blind, where it's actually not going to pierce here, it'll actually pierce on the edge of the material, or you can set it to user will pierce and come in there. So you can see this green line here that represents where the toolpath is actually being projected to. So even though we chose this curve here as the curve for the toolpath, it looks at the model and puts the toolpath at the top of the model there. So that's all we need to do with that one. And if I want to, I can click into this name box and I can rename it. Alright, so next we'll go ahead and program this hole here. So for this one, we'll go back to curves, and instead of picking surfaces, because this is on a couple of different surfaces, might be easier sometimes, I find it to just pick on edges. And so we just click on an edge, and then IGEMS will highlight in yellow the curve that it thinks that you want to follow. If that's not the curve that you want to follow, you can just hover your mouse and click on where you want it to go, but in this case this is what we want, so I can just do N on my keyboard or next, and then next again, and then we've got that curve there. I could pick a similar bottom curve here, but I am just going to use a fixed command and tell it the distance basically that we're projecting through there, so we don't need a bottom curve. So we'll go back to toolpath, and we'll click on the plus button again, upper curve, and where we want to pierce, and hit enter to go all the way around, which direction we want to go around, and then lower curve. We don't have a lower curve, so you just hit enter and then give it information again about the lead in. So we just again hover my mouse till it locks in there, hit enter, and hit enter again for my lead out. Now, since the prior cut that we programmed, that was a vertical cut, this carries over the same settings for that angle there, since we're doing a fixed cut here. So right now that's fixed vertical cut. We can change this to follow whatever angle is in that geometry there. So if we want to do that, we can click on this little edit button here, and then down here we have choices for straight. Can give it 2 points to pick up the angle, specify angle if you want to do that, or auto. So if you just kind of hover your mouse near this geometry, it'll see what it can find for edges in here. So like that edge there is going to give us the angle that we need. So when that's highlighted red, I could click, or I could choose the 2 points and pick the end points of that line there. So, but I'm just going to highlight that red line there, click, left click, and see it projects that curve up to the top surface of the model again, and then we got our angle. And down here it shows us that it's cutting this at 35.16 degrees. And we can click on our little simulate button if we want to get a rough idea what this is going to look like. It's up here in the tool area right now. I've got this set to my die line abrasive head. You can have your different, if you have different head styles, you can have different choices available here. And if you want to define a head style, you can click on this edit button here, and you can plug in what the different dimensions are for your cutting head. So we're going to do this with, we'll say it's going to be the die line water only head. And if you click on here, you can see what those dimensions are, and you can edit those if you need to. So you see it's going to come down, tilt over, pierce, and cut, and that's it. So that's easy enough. So next we'll go ahead and program this cut here on the end. So there's a couple ways of doing this one. Of course, there's always at least a couple ways to program these parts. So we'll go ahead and click on close. So your first inclination might be to pick the top edge and pick the bottom edge and program it, and that might work out fine. What you'll get is the cutting head will start at one angle, and then as it's going through here, it's going to change the angle, because when it starts, it'll look at from here to here to give it basically angle here, and then as it's going along here, it's going to start tilting over at whatever angle this face is till it's at the end here and it's pointing out this way, which if your cutting head is perfectly calibrated, that might be fine, but a lot of times if your head isn't in perfect calibration, you'll see a little bit of a deviation at the top or the bottom. And if you did this at a fixed angle, if you do have any, if your head isn't perfectly calibrated, it's not going to be quite as visible. So I'll show you a couple ways of doing it. So we'll do it first way here. Sorry, click on curves, and we'll pick the top edge, and then we'll hit enter, and we'll pick the bottom edge and hit enter, and click on close, and do toolpath again, click on my add button, and start here, end here, and then pick this as my lower curve, and then put in my lead in and lead out. Enter on that, and then I'm going to give myself just a little bit of extra lead out to make sure that it's going to get past the end of the cut there. So you see how these projection lines, the tilt changes as it's going through this cut here. So that might be okay, but what might give you better cut quality is actually if we pick this lower curve and then pick up the angle up here to give us the angle for that cut. So I'm going to delete that cut, and I'll click on add again, and I'm going to choose this as my upper curve, start here, end here, no lower curve, so I'm going to hit enter, and then I'm going to add my lead in and lead out. Now again, it picks up the angle from the last cut that I did, which is why it's slanting in this direction here with that 35.16 degree. So to change that, I can click on this edit button here again. And again, I can just hover near an edge that gives me the angle that I'm going to want. So I can just left click there, and then it picks up that that's 25.78 degree angle. And then you can see these projection lines are going nice and straight through there. Alright, now my engagement is set to upper to lower, and that's for abrasive cutting especially, that's what it uses to calculate the feed rates. So it'll calculate the feed rates based on essentially the length of these red lines here. So for a situation like this, we can change the engagement to either tool to lower or tool to table, especially if it's for abrasive cutting. Now for water only cutting, I have my post set up where it's going to do this at a fixed feed rate no matter what this is set to. But if you're doing this for abrasive cutting, you'd want to adjust your engagement to be from tool to either table plane or tool to lower, which in this case there's no lower curve, so it doesn't really change anything. And then your feed rates are based off of the length of these red lines instead. And then if we want to make sure that we're going to actually get by here and cut this all off, we'll want to extend the length of our lead out here a bit. So I'll extend that to 1/2 inch, and then I can probably bring it back a bit. Okay. And I'll go ahead and rename this one. Alright, so next we're going to program this cut here, and if things get a little bit confused with all the different cuts over here, you can come over here and you can turn off toolpaths if that makes it a little bit easier to see what you're working with. So for this one here, for our upper curve, we've got obviously this edge here that we can choose. We have this edge here, but then we don't have anything in here. So we can either use CAD and draw in some lines that we can use to pick edges, or as we're picking edges, you do also have the ability to draw in edges as you're doing your selections. And then when we start, probably want to start somewhere off the edge, or at least over here somewhere. Because if we start our pierce here, the jet's going to want to be basically projecting along this edge here, and then it's going to be tilting as it's going along, and probably won't look that great. So we can extend that edge a bit, and then for the bottom edge, we'll basically again need to draw in a line as we're picking our edges and go across here. And then the final thing is when we're coming out, we'll be able to pick an edge and define an edge along here, but then again, for best cut quality, we'd probably want to have that same length of an edge projecting out here so that that head stays at a nice fixed angle all the way through this entire cut. So what I will do here, show you a couple different ways I can do this. If you want to do this all through CAD, we can draw lines in. So I can go to my CAD tab and I can go to my line command, and I'm just going to draw a line from the right click center of here, and I'm just going to draw it to the end point of there, and I'll hit enter, and then I'm going to use my copy command, and I'm going to try to click on that line, which I might end up getting the model, which I do. I'm just going to drag a box from right to left, which will select the line, and then if I hold down my shift key, then I can deselect the model which I didn't want. So I'm just copying that line. I hit enter. Base point, I'm going to copy it from the end point of here down to the end point of here. So I could also draw in my lines here and here to pick my edges, but I'll go ahead and do that separately. I am going to extend this edge here out. So in my CAD area, I've got the option to extend a line. So I can click on extend, click on the edge that I want to extend, and then I've got different choices down here as far as what I want to extend it to. I can give it a distance. Easiest one for this case might be to select surface, and I'm going to extend that edge to that surface there. So that's where we'll end up doing our initial pierce, so we get a nice fixed angle all the way through there. So on our cam tab, we'll go back to curves, and we're going to pick edges. And if it ever gets confusing when the model's transparent like this, you can do Shift Z to make it solid, toggle back and forth between solid and transparent, or that is also a selection that you can choose over here. Shift Z. Alright, so select edge, we're going to start here, and then we're going to go to here. I don't want to follow this edge here, I want to come straight over here, and I don't have a line there, but you do have the option down here to draw in a line essentially. So I'm going to click on line, and we're going to take it over to that endpoint there, and then I'm done with my line command, so I click on done, and then this is where I want to go next, so I can just click on next. So that gives me that edge. I'm done selecting edges, so I can click on done. So that gives me my top edge, and then I can do same thing for the bottom. Click on pick edges, and we're going to start here. Don't want to go this way, I actually want to come across here, so I'll go back to my line command, and right now it's got my line starting at this end of my edge. I want it at the opposite end of this line here, so down here at the bottom you have the choice to change start point. So now my line is coming from that end of my line, and I'm coming over to here and hit enter. So, and then we do want this edge here, so I can do next, and then I want to come this way. I don't want to go this way, I want to come this way, so I click on this line here and then hit enter. So now I've got my top and bottom edges there. So now we'll go ahead and add toolpath to that. So click on my toolpath command and click on the plus button, select my upper curve, my start point and my end point, and then click on my lower curve, and then add my lead in, hit enter, and then give myself a little bit of lead out here just to make sure that I get past the edge of the part. So I can see here where the projection lines are going. When it gets to this corner here, it's getting a little bit confused about where it needs to be going. So again, we can go back and change this. Rather than being a ruled cut, we can change this to a fixed cut, and we can click on this edit button here again to pick up what the angle should be. So, and then we can find an edge that has that angle on it, so we'll pick up that as to be the angle, and now we see we've got a nice fixed cut going through there. And again, there's this checkbox here where if you just want to see the toolpath for the cut that you're actually working on, you can uncheck that checkbox so you can see a little bit clearer what you're working with. And then we can do our preview. So it'll come down, comes down to the angle, pierces, stays at that fixed angle throughout the entire cut, and then off. And we'll rename that. Okay, and then finally we have the outside cut we need to do. So we'll click on close. So for this one, we're basically going to follow these edges along here, and then when we get to this point here, we can follow this as our edge and use that to finish that off there. So we'll go ahead and go into our curves and pick edges again, and I'll just start there. So we'll do N on that one, and we'll come up this way, and then that edge, and then we'll take this edge here, and next, and next. So that should give us our outside cut. Click on close, toolpath, plus, where do we want, upper curve, and starting here, hit enter to go all the way around, and we'll go in that direction. Lower curve, just hit enter, and then give it the lead in, hit enter, maybe get a little bit of lead out, and that should be it for that cut. And then again, for abrasive cutting, you'd want to make sure that you set your engagement to something like either you'd want to set it to tool to table in this point here, since we don't have a lower curve, and then it would calculate the feed rates based on that distance. And we'll just rename this. So I think we've got that. So the other thing we can do is adjust our rapids between our cuts. So we've got those cuts there. Click on close. Now I've turned off my toolpaths, so I can turn those back on. Right now our rapids between our cuts going all the way up to the top of the Z-axis travel. So we've got our rapids button normally that we can click on here to adjust that. If this ever happens where your rapids button is grayed out, then you want to look over here and see that this flat mode button isn't turned on. So we'll turn that off, and now we should be able to adjust our rapids. So we'll lift a 1/2 inch between cuts. And then we'll do a simulation of the full part here. Okay. And one thing you'd have to be careful about in a model like this, especially if this angle were steeper, is that you're not actually dragging on the material that's out here. In this case here we're okay, but if this angle were steeper, you might actually be dragging on the material, and because there's nothing in the model showing that, IGEMS wouldn't give you any warning that you have a collision. If you ever want to check that, you've got the option to basically have IGEMS also look at the stock of material that you're cutting this out of. So under your parts submenu, you have the choice for stock, and if you choose flat material, basically draws a cube around that, and then you can check this box here to use for collisions, and then if it sees that the cutting head is going to drag on that, then it'll give you a warning. Again, in this model that's not the case, no collisions, but you do want to keep an eye on that if you get a similar model to this and you're tilting over to a steeper angle. Okay, so that all looks good, so we can go ahead and create our part, and I'll change my file name. So if we are just cutting a single part, select the part, do your order button, always make sure you click on the part button here. There we've got our Z height, 2 inches. Close that, so that's the thickness of the model, and then we can go ahead and do our full 3D simulation. So then here we have a preview of the code. So at the beginning of the program we're going to come up 1 inch and then we'll wrap it over any A or C axis motion and then come down to our starting height, turn the water on, slight delay, and then do the first cut. Lift up 1/2 inch, rapid, A and C rotate for the slotted hole, comes down to Z0, water on, and continues on like that. So down here you got a slider you can adjust if you want to go through a little bit quicker. You'll note for the water on code I have this one set up where it's M60.01. This would be for a multi-headed system, so if you had a system that had one 5-axis head and one 2D head, and assuming that the 5-axis head was on head 1, this would only allow the water to turn on automatically on the first head, so you couldn't accidentally run a 5-axis program on the 2D head. If you have a machine that has multiple 5-axis heads, we would just modify that post, so just put out the M60 to turn on all heads. And then at the end of the program we rise up 1 inch. Now note that these lift heights that we have here, so at the beginning we're lifting 1 inch, and then between the cuts we are lifting 1/2 inch. So the 1 inch lift is something that I put into the post, so it's going to raise by that amount at the beginning of a 3-axis or 5-axis program. And then between the cuts it's using the rapid height that was in the 5-axis 3D-5X program. Now if we close out of here and you click on this button here, you go to strategy and you go down to your cutting area. These boxes here determine whether it's going to pick up those lift heights appropriately from a 3D 5-axis program, and then these numbers here aren't used with my post through the 3D 5X programs. So even if I change these to something like 2 inches and 2 inches, and then I do my simulation, we'll see that the Z heights remain what they were. 1 inch lift at the beginning of the program, and then the 1/2 inch lift between the cuts that we had specified with the rapids in the 3D 5X area. These numbers will come into play if you're doing a regular part from the 2D area, but for the 3D 5X programs these numbers don't apply. But what does apply is that you do want to tell it that you want to lift, and then it will recognize those rapids. So if I were to switch this to, I'll put it on no but ask. So we'll see here we do the initial lift rapid, and you see that it comes down to the half that was in the rapid, spins, then comes down, and then between the cuts it's actually going to move in a diagonal fashion X, Y, and Z from the end of this cut up to 1/2 inch and then spin around and then come down. So that's the difference between if you have that lift height set to yes or no. Normally I'd prefer to have this set to yes but ask. So if you're going to nest this onto a sheet of material, one little thing that's different here is we'll go onto our nesting tab and we'll click on auto and we'll select our part that we want to nest, select sheets and obstacles. I don't have any sheets on my screen right now, so I'll just hit enter, and we'll say that we'll nest 100 of these, and I'll go onto my sheets tab and I'll put these onto a 48 by 96 sheet. Doesn't really matter for right now, but we got our collar width on our sheet. We'll give ourselves 1/2 inch collar, one sheet of that to nest onto, and we got our gap between our parts here. So IGEMS will look at the projection of the stream and adjust the distance of the parts between based on what it sees here. So even though we have this tool path that's out here off the material, it will look at that, and it's not going to nest a part 60 thousandths away from this edge. It'll nest it 60 thousandths away from this curve here. And if you want to override that, you can always click into here and change that. So we'll just click on stop for right now and OK. So you can see how it's nested those. So the key thing here is if you nest a 5-axis part like this that came from the 3D world, is when you go to add set your 0 point on the sheet. In this area here right now, Z is at 0. And if I went and did a simulation of this, we would see that our Z heights are going to be too high. So we'll see here that it comes around and goes to Z2. So if you started your cutting head with the cutting head 1/2 inch off the top of the material like you normally would, your cutting head would actually end up being, in this case, 2.5 inches off the material. That's because we've got our Z 0 point at the table. So you just have to be sure that when you do nest 3D 5-axis parts, after you set your order button, you come in here. Now if I click on part, as we did for the single part, now it sets our 0 point for the sheet here, which isn't particularly convenient. So what you can do is pick up the Z distance that's here, or just remember that it's 2 inches. In this case, it's fairly easy. And we'll go back and stick this on the corner of the sheet, but we want to change this Z to be 2, so you click on this 2D, 3D button and can put in your 2 there. And now our Z values will be correct. So now at the beginning of this cut here, it's going to wrap it over and then come down to a Z height of right basically 1/2 inch off the material where we want to start from. One final note is when I initially started this program, when I went into 3D 5-axis world, we had this set to a foam and it was 3/4 inch. Now this is actually 2 inch. If you don't have a 2 inch material, then you'd want to add that on there. So you can come in here and add in a 2 inch material. And then adjust your piercing times as such as needed. And then that way, at the header, it'll show the actual thickness that this is programmed for. So if you have any questions on that, let us know. Thanks.